Welcome to the video on velocity versus time graphs. A velocity time graph is a graph that shows the relationship between the velocity and time of a moving object. The slope of a velocity versus time graph gives acceleration. So looking at this graph, the slope is the rise over the run. The rise on the y-axis is the change in velocity. The run is change in time. The definition of acceleration is the change in velocity over the change in time. So the slope of a velocity versus time graph is acceleration. Here we have a direct linear relationship, which means this object has a constant acceleration. It's important to note that on the y-axis, we are learning about velocity. So this object has a positive velocity because all of the data lies above the x-axis, so 0, 5, 10. This object has a positive velocity and a positive acceleration because the slope is positive. And you can see that those signs match and the object is speeding up from 0 to 35 meters per second. This relationship also shows a constant acceleration. Ideally, this is a constant slope, but it's negative. So this object has a negative acceleration, but please note that the velocity values are still positive. So this object is going positive 35 meters per second to 25 meters per second. So this object is moving in the positive direction, but slowing down. This example of the velocity versus time graph, the object is moving at a constant velocity. Let's say right here is 5 meters per second. At every point in time, the object has a velocity of 5 meters per second. So a horizontal line on a velocity versus time graph shows a constant velocity, which is an object with a constant speed in a straight line. An object that has a constant velocity has 0 acceleration. You can also tell that the acceleration is equal to 0 because the slope of a horizontal line is 0. Acceleration is not always constant. Sometimes the acceleration of an object changes, and that is shown by a curve on a velocity versus time graph. To find the instantaneous acceleration on a velocity versus time graph, you would take the slope of the tangent line at each point, just like how you find the instantaneous velocity on a position versus time graph. In this case, the object is increasing in its acceleration because the slopes of the tangent lines are increasing. For this example, we can study the motion of the object. Starting at 0 seconds, the object has a positive velocity because we're above the x-axis, and a positive acceleration. This slope is a direct linear relationship. So the object is speeding up in the positive direction from 0 to 1 seconds. And then at 1 second, we see a constant velocity of about 12 meters per second and 0 acceleration. So we have a constant positive velocity. The acceleration is equal to 0. So what's happening overall is somebody starts at 0 meters, or they start from rest and they increase their velocity to 12 meters per second, and then they maintain their velocity. From 1 to 5 seconds, the person is still moving, but they are moving at a constant velocity. Finally, we're able to study displacement as well on a velocity versus time graph. So velocity versus time graphs tell us about acceleration and displacement. In order to find the displacement on a velocity versus time graph, we study the area beneath the curve. What that means is we look at the area between the graph itself and the x-axis. So this area and this area. It is often beneficial to split up your graph into shapes that you know how to find the area of. So I would split the total area, into 3 shapes. I would say area 1, area 2, because that's a triangle, and then finally area 3, I can study that rectangle. It's important to remember that velocity and displacement are vector quantities, so the direction matters. Area 1 is beneath the x-axis with negative values, so this area is actually negative. If we were studying distance and speed, we would not include that negative. The total area or displacement is negative A1 plus area 2 plus area 3. So recall the area of a triangle is 1/2 base times height. The area of a rectangle is length times width. So the area of triangle 1 is equal to 1/2 the base, which goes from 0 to 3. So 3 times the height, we go down to 10, plus the area of triangle 2, 1/2 of the base from 3 to 4, right? That's 1 second. Times the height, again up to 10. And then we do the area of that rectangle, area 3, length times width. Length, we go from 4 seconds to 9 seconds. So a length of 5 seconds times the width or the height of 10. So this total area or displacement comes out to be let's see, 40 meters. So the first area is negative 15, the second 5, and the third 50. That comes out to negative 40 meters for our displacement.